All right, so I'm just going to keep going with some more examples of what you might see on your unit exam. So the next one we're going to do is square root of 25 over the fourth root of 16 minus 3 plus 12 divided by the cube root of 64. So a lot of stuff going on in that problem. So what you want to do is just make sure you take it step by step. And this one, actually, they have pretty nice numbers, so you'll be able to figure out the answer of each radical problem. So like on the top of this fraction, the square root of 25 is just 5. The fourth root of 16, so you need something that times itself 4 times equals 16. This one happens to be 2. You can also use your calculator to figure those out. If you don't know which kind of calculator to get, make sure you ask me and I can give you some suggestions. You can also use an online calculator. And then I'm going to leave the minus 3 the way it is, the plus 12 the way it is, and then I'm going to simplify this cube root of 64. So I think the cube root of 64 is 8, but I'm going to check. So I need to know if 8 times 8, oh no, that's not it. Let's try 4. 4 times 4 times 4. So 4 times 4 is 16. 16 times 4 is 64. So yes, so the cube root of 64 is 4. And now I just need to make sure I use the order of operations here. So order of operations, you're going to multiply and divide before you add and subtract. So 5 divided by 2 is 2.5. Minus 3 plus 12. Oops, not plus 12. I'm going to do this division over here. 12 divided by 4 is 3. And now I'm just going to add and subtract left to right. So 2.5 minus 3 plus 3, since minus 3 and plus 3 are just opposite operations, I'm going to get I'm going to get negative 1/2, and then I'm going to add 3 and get back to 2.5. So my final answer would just be 2.5. So even though there was a lot going on in this problem, I just took each piece individually and then I applied the order of operations. So remember to multiply and divide before you add and subtract so that you get the right answer. So next, we will look at rational numbers. What kind of numbers are rational? So the question will probably say, which of these are rational? Remember, rational means it's a number, either a whole number, an integer, or something that, a decimal that repeats or terminates. It's not a long string of numbers with no order to them. That's irrational. So rational numbers are kind of the nice numbers. So if they gave you square root of 5 and they said, is this rational? Well, you could try it on your calculator. And when you do that on your calculator, you will get some big long decimal. There's no number that times itself equals 5. How about the square root of 1? What number times itself equals 1? Well, that's just 1. So this one would be rational. Square root of 4. If you do that on your calculator or in your head, the square root of 4 is just 2. So this is rational. Square root of 7. Again, if you do that on your calculator, you're going to get some big, long decimal answer because there's no number that times itself equals 7. So rational numbers are the ones that terminate or repeat, and irrationals are those big, long decimals. So these are the two that are rational in these examples. I'm going to stop this video, and I'll make another one in a minute.